Alright guys, this lesson is a lesson about average rate of change. We have learned that it means the same thing as the slope, and we will be looking at graphs and figuring out the rate of change. Alright, taking a look at problem number 1, alright, this is the interval over which we are to find the rate of change. Please understand that when they give us an interval like this, they're giving us x values. Alright, this is x1 and this is x value number 2. Alright, so we're supposed to find the rate of change between these two x values. That's important because when you set up your table of values, like we always do, alright, these two values that they gave us will be our two x values. Okay, so I've got -4 and I've got 0. So I just need to find the y values that go with these x values. So okay, so I'm going to go to an x value of -4 and look around. So let's see, get some perspective here. Alright, so here's an x value of -4. I look down, 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 and kabam! This is the point I must be talking about. The point -4, comma, -3, because that's the y value. Alright, so let's put that on our chart. -4 goes with a y value of -3. Okay, now how about an x value of 0? Let's take a look at that. Okay, so here we are at an x value of 0. So I look up and I see that here's where the function is at an x value of 0. This is the point 0, comma, 1. So that's what we're dealing with. So 0, comma, 1. So once we have both of our x's and y's, we can go ahead and use the slope formula to calculate the rate of change. That's y2 minus y1 over x2 minus x1. Okay, so y2 minus y1. So that's 1 minus -3. Now, I caution you, some kids make a mistake and just put 1 minus 3. I see this all the time. Alright? If this were a positive 3, we'd do 1 minus 3. But it's not. It's a -3. So be sure to do 1 minus -3. It's like a double negative right there. And then, same thing here. I'm going to do 0 minus -4. So 0 minus -4. A good rule to use, if the second number is negative, put it in parentheses like I just did. Now hopefully you understand that minus a negative is the same thing as addition. So this is really 1 plus 3 and this is really 0 plus 4. So that's going to give us 4 over 4, which equals 1. So for number 1, the rate of change is 1. Let's move on. Okay, so we have these x values. Alright, this is x1, this is x2. Let's make our chart, our xy table. Okay, so we have -10 and we have 2. So let's go to an x value of -10 and see where the function is. Okay, so here's 0. So we look over until we get to -10. So here's an x value of -10. I see that the function is down from here. So I look down, 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 and kabam! Here's where the y value is at an x value of -10. In other words, what we have here is the point -10, comma, -6. So -6 is the y value. Let's put that on the table. -10, comma, -6. Alright, let's look for an x value of 2. We slide on over. Here's an x value of 2 right here. I see the function is up from here a little bit. It's right here. Okay, the y value, of course, is 1 because this is the point 2, comma, 1. Okay, so 2 comma 1. So these are the two pairs we will be dealing with. So we can go ahead and do the slope formula to find the rate of change. Make sure you put your y's in the top. y2 minus y1 over x2 minus x1. So let's see. I'm going to call this y2 and this y1. So remember, don't just put y minus 6. This is y1 minus negative 6. When the second number is negative, put it in parentheses. And same thing here. I've got 2 minus negative 10. All right, and again, when you have minus and negative, that is addition. So this is really 1 plus 6, and this is really 2 plus 10. So this is 7 over 12. All right, and that is the rate of change for problem number 2. And problem number 3. These are x values. This is x1, and let's consider this to be x2. Let's find an x value of negative 2 and see where the function is. Okay, here's an x value of negative 2 right here. Now I see the function is below this, and it is 2 down from here. All right, so I see the y value is negative 2. So in other words, I'm looking at the point negative 2 comma negative 2. Let's put that on the chart. All right, well, first of all, we had to make the chart. And these are the x values, so put them in the x column. But we just found that the y value that goes here is negative 2, because it was the point negative 2 comma negative 2. Now let's find the x value of 3 and see where the y value is. All right, here's an x value of 3. Okay, now I see the y value is down from here. And kabam, it is here. Now, you should be able to tell me the rate of change between these 2 points right now without doing any calculations. Go ahead and say it out loud. Let people think you're crazy. Hopefully, here's why you should be able to tell me the rate of change without any sort of calculations. Okay, this segment shows you the average rate of change, in picture form. And what's, at a glance, what's the slope of this line, guys? Yeah, this line has slope 0. You know this because it's a horizontal line. So the rate of change is the slope. So the rate of change will be 0. Okay, 3 comma negative 2. Now, if you were going to blindly do the calculations, you should come up with the same answer. So once again, here we go. y2 minus y1 over x2 minus x1. Now, both y2 and y1 are the same number. So we've got negative 2 minus negative 2. Put that second negative 2 in parentheses. And then we've got 3 minus negative 2. Okay, minus and negative is addition. So this is negative 2 plus 2 and 3 plus 2. But negative 2 and positive 2 cancel each other out. So that just makes 0 over 5. And 0 divided by anything is 0. So just as we knew from the graph, the rate of change is in fact 0. All right, these last couple problems are word problems involving rate of change, so we can really get a feel for it. Now, when you're doing a word problem, there's a couple things to keep in mind. And one thing is the units. Word problems will have units, and they are not optional, okay? Remember, a rate is something like miles per gallon, feet per second. If you're talking about how much gas your car burns, fuel economy, you might say how many miles does your car get to the gallon. Or if you're talking about how fast your car goes, you might say how many miles per hour is your car going. But that rate, you know, as a fraction, like for example, miles per gallon, these are the units that we're talking about. So I want to see something similar for each of these word problems in terms of units. So let's see what we're talking about. According to census figures, the population of Savannah, Georgia, was 31,194 in 1980 and 34,506 in 2010. So let's talk about the units before we even get started. Okay, obviously the population is increasing. Okay, went from 31,000 something to 34,000 something. So we're talking about the rate at which the population is growing. So it would make sense to talk about how many people per year is the increase. So that's the rate that we're talking about. We're talking about people per year. Okay? Because we have this population increase, but is it increasing by 100 people a year? Is it increasing by 500 people a year? But either way, we're talking about how many people per year. Now, so remember, when we do our slope formula to find the rate of change, we're going to be doing, let me change colors for a second. We're going to be doing y minus y over x minus x. So please understand that people will be the y values and the year will be the x values. Okay, so that's one big thing to keep in mind. There's one more thing we have to keep in mind. When we're talking about, well, no, you know what? Never mind. So let's look at these, the people and the years. So first we have 31,194. All right, this is people. So is this an x value or a y value? Okay, let's see. So this people, that's going to be a y value. Do you understand what I'm saying? Whoops. Let me switch like this. So people are a y value. So I'm going to call this y1. All right, we're talking people per year. People are y, year is x. And then 1980, okay, and let me switch colors. I think I'll go blue with it. All right, so people in 1980. People is a y value, and then 1980, that's a year, so that's an x value. So in terms of the sentence, they're backwards, but that's why the the units are so important. People per year, y value, x value. So from there, it's easy now that we understand that people are y values and years are x values. So what happens next, guys? We have 34,506 people. So again, people, that's going to be a y value. Okay, so this is clearly y2. And then we have 2010. All right, again, that's a year. So that is, once again, going to be an x value. Okay, so now we can go ahead and make our chart. But it's, you got to be very careful what's your x values and what's your y values. Okay, you know what? I think I'm going to need a bigger chart. Let me stretch out my chart a little bit more. Okay. So x1, y1. x1 was 1980. And then x2 was 2010. All right, y1 was 31,000. You know what, maybe I'll do it in red. Y1 was 31,194. And Y2 was 34,506. Okay, so now it's time to set up that formula. Okay, of course we're doing Y2 minus Y1 over X2 minus X1. That's what's happening. Okay, so first the Y value. So I'm doing 34,506, that's Y2, minus 31,194, that's Y1. And now I'll do the X's in blue, like we had it. So X2 is 2010, and X1 is 1980. Okay, so let's crunch these numbers. Let's use our calculator. Okay, so we are going to do, all right, hit your fraction button. So let's do 34,506 minus 31,194 over, all right, 2010 minus 1980. And just hit enter. Okay, now this is saying that it's 552 people for every 5 years. But we don't want to leave it as a fraction like that. For a word problem, you're pretty much always going to go to the decimal. Okay, because we want to know how many people per year it is. So it's 110.4 people per year. Now obviously you can't have 0.4 people. All right, let me see if I can move this over a little bit. Okay, so we had 110.4 people per year. Okay, and again, the units are important. So don't just say 110.4. Say 110.4 people per year. Okay, that is how you do a word problem. All right, I'm going to do this one quicker now that you hopefully have the idea. Number 5. Okay, Neiman's Gravel Company will deliver 12 cubic yards of gravel for $180 and 25 cubic yards for $450. What is the average rate of change of the cost as the number of cubic yards varies from 12 to 25? Okay, so in the end, we want our units to be dollars per cubic yard. By the way, that's how this is read. Don't say yards cubed or yards to the third power. They're saying a cubic yard. So when we talk about how much gravel costs, we talk about it in terms of, oh, it costs, you know, so many dollars per cubic yard. So that's the units. So again, that means we're looking for the dollars, should be the Y values. Okay, so we're talking about Y2 minus Y1, that'll be the dollars. The cubic yards should be your X values, X2 minus X1. Okay, So let's match them up. Okay, so we have 12 cubic yards. We want the cubic yards to be the x value. So this is an x value, and this is an x value. Okay, so let's call this x1, and we'll call this x2. And then we wanted the cubic yards, no, we just said that. We want the dollars to be the y value. So we have $180 and $450. Those are the y values. Okay, so this will be y1 and y2. Okay, so let's go ahead and set up our table. Okay, so first the x's. So I've got 12 cubic yards and 25 cubic yards. And I've got, for the y values, I've got $180 and $450. Okay, so let's go ahead and calculate the rate of change, which is just the slope. Okay, so I need to do y minus y over x minus x. Okay, so that's 450 minus 180 over 25 minus 12. Okay, so let's go ahead and calculate this out, but whatever we get, don't forget to include the units. I would like to do all this on my calculator if you don't mind. So that's what I'm going to do. Hit your fraction button, and then let's do 450 minus 180 over 25 minus 12. Okay, we definitely do not want this fraction. For a word problem, use decimals. So hit your toggle key, and you get this. Let's go ahead and round it to the nearest tenth, one decimal place. So I'm talking about 20.8. Let's go ahead and say 20.8. Okay, so this is $20.8 per yard. All right, so that means on average, on average, this is how much you're going to be paying for every cubic yard of gravel. You're going to be paying $20.80. Okay, and that is the end of this lesson. I hope it was helpful to you. I will see you guys on the next video.